everyone. First of all, I would like to thank Ms. Pana for giving me this opportunity. Ceiling fans. When you really mention that, the reaction is, okay, what about it? Here we are really talking about sustainability, and with Superfan we believe that we have something to offer towards that goal. We were a company manufacturing variable frequency drives for industrial application. How did we really get into manufacturing a super efficient fan? The seed was sowed right here in Bangalore in 2009. When we were here attending a seminar on semiconductors, one of the managers asked, "You guys are experts on variable frequency drives, can you develop a drive for efficient ceiling fans?" The first thought was we brushed aside. We said we are not into consumer goods. We make high reliable industrial systems. But my partner Durga came across one article from NGO called Prayas from Pune, which talked about the overlooked appliance, which is the ceiling fan. If you see these figures, it's really amazing. There are about 350 million ceiling fans operating in India, and if you assume only even 7 hours a day at medium speed, it consumes 39 watts. That creates a demand of 13,650 megawatts. Even whole of Tamil Nadu or whole of Karnataka does not need that much demand. Ceiling fans require that much. And 95,000 million units per day, and this market is growing at 6% per year. So that really inspired us. We said, why not we really look at it? When we looked at the fans market, we saw that fans were invented about 120 years ago, and in India they are present for the past 75 years. They basically have induction motors, single-phase induction motors, which are not efficient. They are constructed with steel or aluminum. They have a regulator for controlling the speed. The regulators used to be resistor-based, which used to melt every 2-3 years, occupy a large space on the wall. Now you have compact electronic or capacitive type regulators. And we said, okay, how do we really make it more efficient? We are looking at permanent magnet DC motors, which had its own problems. It needed an electronic drive, and magnets had to be there, which was costing more. Then when you have electrical drives, it introduces harmonics into the electrical system. Then the carbon brushes. So we decided on really improving upon this permanent magnet DC motor, and we worked on all these things: magnets, electronics, harmonics, and the sensors. Then we decided, are we going to make just another fan? Low power consumption. That's the main reason why we thought about making fans. High speed. In India, we require fans to run at very high speeds, because it is not merely for air circulation, it is also for driving away insects. And here some of the speakers before, they talked about how the ventilation systems are really missing in the new homes. So you really need to drive a lot of air to get even little comfort. Stable speed. The regular fans, they vary along with the supply voltage. The supply voltage goes down, which is happening in India in most parts. The speed goes down, or when it goes up, the fan runs very fast. Power factor correction. then the new fan had to be installed in the same way as the regular fan. It can't be different. We can't really educate the electricians here. Remote. All the appliances at home have remotes now, so we said let's have remote for ceiling fans too. Low cost. See, this type of fan is not really like new. It's available abroad. They cost anywhere in the range of $200 and above, but that's not affordable in India. So we said, okay, we need to bring in at a cost which is affordable. Stylish. That's something we always do whenever we make any product in Versatrice. We make it really stylish and appealing. Then this is something we try to do our bit towards sustainability. So we decided that we would make a super fan. So what is the specs for the super fan? It's at 35 watts. 35 watts at any regular fan, how much ever air they would deliver and whatever speed they would run. So that's the market standard. We went a little above. 375 is normally what the other fans run. We run at 385 RPM. Then super fan, the speed doesn't vary for input voltage variation of 160 to 260 volts AC. That's for the specs, but unofficially it can run from 130 to 300 volts. Power factor of 0.9 and above. Wiring same as the existing. We have a remote with 5 speeds on off. It's very similar to the regulators what we have. Then for greening the product, we use ROHS electronics, VOC free paint, and recyclable packaging. If you look at Superfan's packing, you will not find any plastic bags or thermocol. And even the printing on the packing is very minimal. And the air delivery of 230 meter cube per minute. The ceiling fans are rated by Bureau of Energy Efficiency. How they do the rating is with the service value. The service value is how much air is delivered per watt consumed. So the 5-star rated ceiling fans have a service value of 4 and above. That's what the energy efficient fans you will find in the market, delivering 210 meter cube per minute, consuming 50 watts. You can compare that with a super fan, which has 6.57. The benefits. Mr. Hari Krishna was talking about, the customers are concerned about the benefits. Superfan does not use any regulator, so you save money on it, save space on this switchboard also. This fan, because of its low loss, runs really like cool. The fan doesn't get heated up when it runs for a long time. Of course, nowadays these inverters are in large use because of the power failure. Superfan runs twice more longer, or you can run more fans using the same inverter capacity. We have a small microcomputer inside Superfan, so that really does a lot of things like this remote control, and it can also, if you are interrupting the fan's rotation, then it trips. We also have an indication in the fan which is for remote operation, but we use it additionally for whenever you switch off the super fan using the remote, that light keeps glowing, indicating to you that if you are not going to use, you should switch off at the wall. This is something we normally do with TVs. We switch off with the remote and walk away. The TV consumes a standby current of 3 or 4 watts. Just imagine in a city, they have about 100,000 TVs, and each of them consuming a residual consumption of 3 watts. That's 300,000 watts, huge energy. So in Superfan, we indicate that you are supposed to switch off. We worked on the blades also. We improved the efficiency of the blades. Then other fans, when they work on the inverter, they make an extra noise, especially if they are a square wave output inverter. Here in Superfan, you don't really like to hear anything extra. We have aluminum die-cast body, aluminum leaves. We have DC models for solar applications. We have 24 volts DC and 12 volts DC fans. Some of the things what we have done is to really like make Superfan last longer. Because I always see that, my fathers had bought fan some 40 years ago, they are still running. It may consume more power, but that was not the criteria for design those days. But what fans I have bought, I already changed once. You see a recent trend, everything you use it for 2-3 years and after that you have to replace. But we decided that Superfan has to last long. So we studied, what are the components which are failing in the regular fans, and we changed all of them. So you can see some of those things I don't want to really explain one by one. We have about 3 models, 2 models in 48 inches and 1 model in 56 inch. We have the brochures here, so I think you can go through the specifications here. So theoretically, the Superfan has an MTBF of 65,000 hours that gives a trouble-free life of 18 years. It can work on wider voltage range, it can work on low voltage also. So that improves the reliability. Because of your voltage batteries, Superfan is not going to fail. Superfan does not get heated up, so it doesn't affect the electronics also. We have EMI filters. We have overload, over voltage protection. The motor also is built with F-class insulation. We use ceramic magnets. The motor does not use any sensors, so that improves the reliability too. It's designed to meet IS standards. We have tested the Superfan in the laboratories. So here is the ultimate thing what everybody is looking for. How does an individual get benefited from using Superfan? If I assume a 10 hours operation and per unit cost of 5 rupees, if the fan is run at the top speed always, then you save about 639 rupees per year. But that may not be the case. You may run at the high speed in summer, medium speed in other times, and slow speed in winter. So if you assume that it's an average medium speed, still you save about 456 rupees. So that's better than bank interest. For large use, we have some calculations here. Say in a hospital, if there are about 1,000 fans, hospitals use fans for a long time. As long as the patients are there, the fan is running continuously. But still we have assumed that it's about 20 hours per day and 300 days if it runs. On average, they pay about 7.5 rupees per unit. So if you have to run on a generator, or even your demand comes down by 40 kilowatts, that's for just 1,000 fans, and the electricity charges is reduced by 11 lakh rupees. This is something not many of us realize. I never realized until I really make the calculations. I had to check it many times, even give it to someone else to check, whether that is really the case, but it is. So if you have assume a 20 years life cycle, at the end of it you would have saved 2 crores. That's how much the fans can contribute. So this is the case of an educational institution where it could be only 8 hours a day, 500 fans, and the working days are only like 240 days in a year. There again the savings are considerable. The ROI is in about 2.7 years. Still the savings are there. 32 lakhs for an investment of 12.5 lakhs. So in India, if Superfan is being used in all the places, you can save 28 crores a day. We hope to really make more exciting models and useful models in Superfan. The underlying technology is the motor and efficient drive. So we would like to use it in many places at home. So at some point of time, the homes become very efficient, they need less energy, and some of the decisions we made are like our motors will always be low voltage motors, so that any time if solar becomes very popular, then these systems can be adapted readily. So now that's ceiling fan or Superfan. This is what someone was talking about. We have made a music video. It's actually part of our advertisement, but we try to influence the young people thinking about energy saving and clean technology, clean air, carbon footprint, and all that. I just requested 3 minutes of your time to play the video.
baby. Superfan, 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 not superstar. Superfan, superfan, superfan. I'm not a super rich, baby. I don't have super clout, baby. Clout, man. I'm not a super rich, baby. I don't have super clout, baby.
Thank you.